Kia ora, Year 12 and 13. Here's question 1b from the 2018 probability distributions paper. So this is quite a mathematical question. It's one where we look at the expected value, the variance, and the standard deviation of a random variable. And the first part of this question, remember, was the one that was all about the average number of emails received per hour. This one is kind of related. The theme is not emails, but the number of mobile phones owned by one person. So the first thing we're given is a table which shows us a probability distribution of this random variable m. And as soon as you see a table like that, you're probably going to be thinking, oh, I wonder what the average or expected value of it is. So up here, we've got the number of mobile phones that someone can own, 0, 1, 2, or 3. Or do own. So we're not really told much about how they got the sample or anything about it. We're just given the distribution. And here we've got the probability that they own 0, 1, 2, or 3 phones. Look, it is worth just looking at those numbers before you dive into the question. Just notice that we've got 63% of people owning one mobile phone, because this wouldn't be a level 3 stats exam if there wasn't some link in the question to context. And that comes down here in part 3. And on average, every mobile phone costs $130. So we have to calculate the expected cost of the mobile phones owned by one person. So this is the number of mobile phones. So the cost of mobile phones owned by one person is going to be equal to 130 times how many they own. And if you see it like that, then we know that the expected cost will be 130 times E of M. Now, you don't need to be confident with expectation algebra to work that out. It just kind of makes sense. If we find the average number of phones and then we times it by 130, we're going to get our answer. But more generally, if we've got a linear combination, so the expected value of A plus BX, then that's equal to A plus B times the average value of X. And in class, I talked quite a lot about if you had some kind of motel that had a fixed charge, right, then this would be A, the fixed cost. Or if you've got a situation with a plumber, like you did back in year 10 when you probably learned how to draw linear graphs, right, this is the charge out fee, something like that. So this is my general formula for finding the average of what we call a linear combination. But we don't have to know all of that to do this question. That's just background. So in here, what we've got to do now is find the average value, E of M. Right, so let's just put that table down again. We've got 0, 1, 2, and 3, and then we've got the probabilities. We've got 0.06. So the expected value is going to equal this times this, this times this, this times this, and this times this, all added up. So you can chuck that into your calculator, or you're going to get 0 plus 1 times 0.63 plus 2 times 0.22 plus 3 times 0.06. And when you add all of that up, you get 1.25 is the average number of mobile phones. Now, don't round that to 1, right? We need to keep that as an exact number. And the cost is equal to 130 times the number of mobiles. So the expected cost is equal to 130 times 1.25, which gives me $162.56. Right, obviously you didn't need to write all of that out, right? So things that you needed to do were, well, that I would do is this line here, and then this line here at a bare minimum, right? So that's the achieved part of the question, and you should feel really, really comfortable with finding an expected value from a table like that. The next part of the question is looking at the standard deviation for a different random variable, which is the number of email accounts held by one person. And we're given the standard deviation, which is 1.4. Now, we never want to work with the standard deviation. We want to switch that over to the variance. So the variance is equal to 1.4 squared, which is 1.96. We have to show that N, the number of email accounts, has got a bigger standard deviation than M, right? So we're going to go back up to here, and we're going to work out the standard deviation for my first random variable. And then we're going to think of one reason why that might be the case. Okay, so we're looking at how spread out are the number of mobile phones that people owned compared to the number of email accounts. So we're going to find the variance, and to do that, I always write in an extra row on my table. So I've got my probabilities here, which are 0.09, 0.63, 0.22, and 0.06. Here I've got my x's. Actually, in this case, they're called the m values. So this is the number of mobile phones. To find the variance, I want to pop in a new row, which is m squared. So I'm going to have 0, 1, 4, and 9. And then I'm going to use the formula for finding the variance. Right? So the variance of a random variable is equal to this. Now we've already got this number from up above, so all we have to do is to work out this one. So I do the same thing that I did before, except this time I'm taking my probability and I'm timesing it by the squared number. Then this probability times this squared number, this probability times this squared number, and this one times this one. So let's write all of that down. So we get var m is equal to 0 plus 1 times 0.63 plus 4 times 0.22 plus 9 times 0.06. And then I have to subtract off the 1.25 squared. So throw all that in your calculator and you should get 0.4875. But remember, the question's asking us to compare the standard deviations. So to go back to the standard deviation, I take the square root of that number. And that works out to be 0.6982. And we're comparing that to the standard deviation of the number of email accounts, which is 1.4. So what do I have to say now? Well, I have to say, well, that's less than 1.4, which is the standard deviation of n. And I have to give a reason why that might be. So think about how many mobile phones you've got. I don't know about you, but I've got one. Most people have got one mobile phone. But for email accounts, you're likely to find much more variation. So you might want to say something like this. So you're likely to find more variation in how many, excuse the terrible writing, I could type this, but I'm not, how many email accounts people own. You'd expect more will have 2, 3, or even more. So why would that be? Well, they might have a really old email account. They might have a school email account. They might have an email that they use with their real life friends and family. And then they might have an email account for, so that school one could be work, right? And they might have one for a sports club or a music group that they run. And so it's pretty easy to see that you're going to get lots of people having more than 0 or 1 mobile phone. So if we look at up here, we had most people in these categories here, which is giving us quite a low standard deviation, because the standard deviation measures how spread out something is. Whereas with the number of email accounts, we're going to have lots more people in these categories and even higher ones. So that's why it's not surprising to see that the standard deviation is higher for the number of email accounts. I'm going to show you the schedule to see what they said in there in a few minutes. Now, that was a merit question, by the way, right? So the maths in there is really not very hard. If you're not confident with that, what you need to do is hop onto Education Perfect and practice the expectation stuff until it feels easy, because it's the same calculation every time. Now, the last question was asking about independence, and this is the excellence question. So you need to understand that if two random variables, x and y, are independent, then the variance of the combined number, so here it's the combination, the add up of mobile phones and emails, is going to equal just the two separate variances added together, right? There's no linking up term here that links up how the x's and y's change together. So if they're independent, then that's true, and the other way around works as well. If the variances, the separate variances added up are the same as the variance of the combined one, then we can say that x and y are independent. And when you answer this question, I think that's where you want to start out, by showing what you're going to do. Right? So we're not going to work with standard deviation. We're going to work with the variance. And the variance of m plus n is equal to 1.893 squared, which is 3.583. So that's the variance of m plus n. It says to support your answer with appropriate statistical statements and calculations. So for me, the appropriate statistical statement is this one here in the box, because you need to explain what you're doing, right? So we're checking whether we get these two added together equaling this one. So we've got variance of m plus the variance of n is equal to 0.4875 plus 1.96. That gives me 2.4475. And that's not the same as 3.583, right, which is this number up here. Therefore, m and n are not independent. Now that kind of makes sense to me. You'd expect people who have more mobile phones to have more email accounts, right? Probably one of those mobile phones is a work one, which probably means they're running a work email account. I don't think you were actually asked to talk about that in context, but you should be prepared to do that. So you're thinking about whether there is a real life link between those two things. And if there is, you should expect to find exactly what we found, which is that the combined variance, which is measuring the spread outness of their mobile phone and emails, is not the same as if you just look at the two separate ones for people. Okay, let's look at the schedule quickly. So that first question, where we found the expected value, that was actually a merit question. Okay, so that wasn't an achieved question. And so was the next one. Notice, as usual, we have to put the in context part to get a merit mark, which makes sense. The first part, the calculation here, will get you an achieved tick, but you need to understand what you're doing. Okay, then the second part was this one here where we looked at the independence of m and n. And to get excellence, we had to explain why they're not independent, and we had to do the calculations correctly. So we have to be showing this thing here, that var m plus var n is not equal to var m plus n. So drop me an email if you want me to make you up some more questions like those, or if you've got any questions at all on this part of the distributions topic. It is one of the harder bits, and I think some people were probably a bit surprised by this question in last year's exam paper. Thanks for watching.